Hey guys, welcome to our ECE 2305 course project final video. My group and I worked on a wireless capture the flag for this course project. This year's challenge was to wirelessly locate and communicate with 4 mystery nodes hidden in Atwater, Kent, and get a digital flag from them. The device that we use to locate and capture the flags includes the HC12 wireless transceiver and Arduino Uno. This is the schematic diagram of our circuit design, and the picture on the right is our Arduino and AC12 connected, which is follow through from our schematic diagram. So the AC12 has 5 pins, and of that, the transmitter pin and the receiver pin are wired with pin 10 and pin 11 of the Arduino, respectively. The ground pin of both the devices are connected to each other, and the VCC of the AC12 is wired to the 5-volt pin of the Arduino, completing the circuit, and we used our laptop to power the Arduino. Overview of the implementation. This diagram here shows how the devices all communicate with each other. So the wireless transceiver communicates with the computer as well as the 4 flags, aka the 4 nodes. To send add commands such as changing the channels of the HC12, the set pin needs to be connected to the ground first. We figured this formula out in order to calculate the specific channels from frequency found in SDR sharp, which is based on the AC12 range of 433.4 megahertz to 473 megahertz within a range of 400 kilohertz. So in total there are about 100 channels. The Arduino code. So we used the software Arduino IDE to program the Arduino Uno board we used for this project. This here is a simple code to receive and transmit messages between the receiver and the nodes. The code checks if there is any data from the HC12, which is then sent to the serial port to be displayed. The code also does the opposite, which is if there is any information in the serial port, it sends it to the Arduino, and then it is transmitted by the HC12 to the destination node. Test node communication. Professor Wiglinski set up a test node outside of his office, which broadcasts on channel 1. That is the default channel of the HC12. Once in the broadcasting range of the test node, the HC12 started receiving messages containing the IP address of the test node. After getting its IP address, we sent a message to the test node following the packet structure. The node's IP address, our MAC address, followed by the password. After being successfully registered by the test code, we then proceeded to capture the flag by again sending this packet where it contains the IP address of the host, our MAC address, followed by get_flag. And here is a picture of us successfully communicating with the test node. Let the hunt begin. Following the process that we used to communicate with the test node, we started looking for the 4 mystery nodes. The locations where we found the nodes are the first floor of AK, which is the ECE shop. Two of the other nodes were located near the ECE department office on the second floor, and the last node was located near Nivita's office, which was on the third floor. This is a video of us capturing the node on the first floor.
Wasn't that the third floor?
It can be 3s and 4s.
I don't know, because we tried a lot with 4s, but we just didn't get anything. We got stabbed. So that's why I kind of stopped going near them.
I think the third floor one was 4, and that's probably because we were
Oh,
close
there we
enough.
go.
There's one. Yep.
Yep, 469.4.
Alright, that gave me channel 90. Unplug.
Plug.
Plug. Unplug.
Unplug.
Yeah, that's it. Okay. Cool.
Oh, it's the same one.
Why am I doing
It's the exact same one.
Okay. What?
No, remember it was just, we didn't really need to do it. We just had to copy this one again, right?
Did I put in our Mac wrong? What's the issue? Yeah, I think I put in our Mac wrong or something. That's aggravating. Alright, tell me if it goes away. I'm really hoping that doesn't happen this time.
Still here.
Okay.
Okay, yeah. Oh my god. Gotta put in the whole thing again. Yeah, so the structure for the thing is first the node's IP address,
Your
Our
MAC
Mac?
address.
our MAC address. Is this ours, right?
Yeah.
Our MAC address, and then
Get flag.
yeah, at this point we just use the get flag command. I have to put another pipe symbol afterwards, and
We have
we
our
have
Yep.
our flag.
Right there.
The struggle is quite real. Some of the struggles that arose while looking for the nodes using SDR Sharp and the RTL SDR includes the antenna, which we initially used had a larger range than the HC12, making it harder to pinpoint the node locations. Each node also broadcasted on different channels, making it harder to communicate with the node, and there were ghost frequencies compromised mostly of noise and would hinder the search, making it difficult to find the correct channels. And after finding the 3 nodes, it became quite difficult to find the last node, as we kept getting messages from nodes which were already found at different channels. So for the solution, we dealt with these issues by reducing the gain to eliminate ghost nodes and reflections, and also using the smallest antenna which we had, since it picked up signals in a smaller range, and also communicating quickly with the nodes once we were on the correct channel by having the package structure already copied and ready to paste. Final remarks and real-life application this project has. Outside this project, transceivers are used in wireless devices to wirelessly communicate with each other. Some of these devices are cordless telephone sets, radios, cellular phones, Ethernet switches, and many more. Thank you for giving us your attention and hope you enjoyed our presentation.